Hi, everyone. Thanks for coming. As Dana said, it came out real quick for today. But what I want to talk about today is some of the work I'm doing with the Idea Maps networking grant and the data ecosystem. Um, and it follows on just what Francis was doing, that the whole interface of data. And one of the things that he's been helping run in the three different cities we're working in is called PAR. What does PAR stand for? Participatory Action Research. And so what they've been doing is going out to people like people who work in the city, people who live in the cities, and getting information from them about slums and what do they look like and how do we characterize them. And then they've been working within the validation tool that Dana just showed and Francis was supposed to talk about to kind of uh, tell whether our models are correct or not. One of the things that came out of our workshops and talking with the community and is the idea of, instead of just going slum, non-slum dichotomy, is there a range in slums? And so what we're trying to do with this work, this is stuff that we're currently working on. I'll be presenting in Tunisia in May next week, is like, can we do a degree of informality instead of just a binary, hey, this is slum, this is not slum? Like, can we go like, hey, this is really slummy, this is medium slum, this is non-slum? And so when people who work on the ground in participation action committees and they talk to people and they say, hey, this is a great idea, and then us modelers go like, how am I going to do this? And so this is our first attempt to go like, hey, how are we going to do this? And what are we going to do? And as you can see, like pretty much everybody who've talked about in the Idea Maps network is on this paper, and we're doing this work together and coming back full circle to some of the stuff and trying to do the modeling and so forth and going through it. And so this is my work, I would almost say, comes in between like Alex's and Cam's like global data sets versus, these people on the ground who are doing it small areas. I'm trying to do it in the middle of like entire cities and trying to understand it. And so that's kind of like how it all starts to piece together. Like, how do we start to understand it on a specific city? I use a lot of remotely sensed data. In particular, I like Sentinel-2 because it's free and open, 10-meter spatial resolution. And then we've been going after all these geospatial data sets. My goal is to use data sets that can be used at the global scale, but then also how do we link it to the local scale? And so that point in between, so free and open source routinely. And then the questions we've been going after is, can we do binary? And Maxwell presented last time, and he was working on his master's thesis here, and we did a really good job at mapping binary slum outputs. We have a bunch of papers that came out on that. If you want to read about it, we can do pretty well within a city. We've done all three cities. But then, like, how well can we do a range in deprivation? So that's what I'll be talking about today when we're going after. So as Monica said, a lot of papers are done in Nairobi. Why? Because you have good data and it's actually pretty easy to see. So this is kind of where we always test like our first ideas, is we test it in Nairobi. If it works in Nairobi, it might be able to work somewhere else. The work I've done in Lagos, if you work in Lagos, if you get anything to work, you're lucky. It's a really difficult city to work in. Also, Accra, I've worked in Accra for forever with Maxwell and different projects, and it's very similar to Lagos. You're pretty good at it. And so one of the things I've been doing is going after Sentinel-2, and then Dana gives me a hard time about this all the time. I use these things called contextual features. I'll talk a little bit about them, but they're these ways that we derive, instead of spectral information from satellite data, we go after the spatial patterns. And that's because, these slums and these deprived areas, they're spatially different. The pattern is spatially different than formal areas. And so we're trying to use this idea to go after this. And collecting a whole bunch of geospatial data, and I'll talk a little bit about that. And then can we do binary? And then how do we go from there to this range of deprivation? And so I don't know if you caught it earlier, but in one of the presentations, I think Dana was talking about this domains of deprivation. And so there's tons of geospatial layers out there now. It's crazy how many of these global data sets they've been created. There's range in quality and how good they are. And so what we've been doing is like, hey, let's see if we'll just take everything we can find about these domains of deprivations on geospatial, it's global. So we go after facilities and services, things like health, roads, finance, schools, housing and buildings, physical hazards. Remy was asking about, slopes, what's your distance to water, all these different things, population counts. You know anything about population, there's a whole bunch of different data sets out there. Well, throw this into the model. Let's do social hazards, literacy rates, pregnancy rates, stuff from DHS, Malaria Atlas Project. We just throw everything we could think of in there in a geospatial variable. Then the second thing I like to use is imagery. I didn't touch on it, but we do use like all the new building data sets by Google and Facebook. They have all these new building data sets out there. Well, are they going to remake them? In the last 3 months, we've learned a lot about, well, what's going to be the future? I'm not quite sure. And so like, hey, Sentinel-2 is a satellite put up by European Space Agency. Hopefully they stay in business. It's hard for all of us to stay in business, but if they give away the data for free, is there a way we can extract information from it? It's a global data set every 5 days. It's pretty awesome data. We're now really good at making cloud-free mosaics, even for really difficult cities. And so this is kind of what I've been pushing for. And so we can do an Earth Engine for free right now. And then I calculate these things called contextual features. We're covering entire cities with this. And so this is what a contextual feature does, is instead of looking at a per pixel, what it does is it looks at a group of pixels. And then it starts to measure things like line support regions, this thing Pantex, local binary pattern moments, Fourier transforms, hog. She was just giving me a hard time about what a hog is. It's actually the histogram of orient to gradient. And what it tells you is like, okay, we break the image into a bunch of lines and let's see how they're oriented. Are they all oriented to 90 degrees? Are they all oriented to 30 degrees? And what we find is in slums, they're oriented in all different directions. Whereas in areas with formal settlements, it'll be all at right angles and stuff. And they'll fall in a certain segment of it. And so this is stuff that you can think about when you picture this in your head of breaking like an image into lines, you can start to see this. This is all stuff that actually was originally done for facial recognition software. It's what your cell phone kind of does when it looks at you. And this is, and it knows, it can break up the features of your face. That's how it knows that it's you and unlocks it. These are the things that do this. What we're doing is applying it to satellite imagery and seeing what we can pull out of it. NDVI, measure of vegetation. And then what we're able to do is look at it on a pixel and then outside that pixel, like 70 meters. And so what happens is, this is a huge thing about the definition of a slum. It's actually not one building, but a lot of the stuff is based on the household. So where do you end it? Oh my gosh, everybody has a different thing. So this allows us to do it without making that decision and then come up with statistics and values that then you can correlate with different features. And that's what we're trying to do and see what's going on. So it creates 432 layers. When we output this, we run it through our supercomputer, it takes a few days. This 432 features plus the 53 geospatial variables. And this kind of gives you an idea. It's a really poor picture, a bad resolution, but what happens is Gaber, lacunarity, mean, and DVI, they'll be different between the different areas. And this is part of what Maxwell's master's thesis was looking at, is just using the contextual features to go after it. But what we do is we process all the raster data, the polygon buildings, the rivers, roads in different ways, come up with these measures. And as Dana talked about, we do go everything to a 100-meter grid cell. And we aggregate everything to a 100-meter grid cell. This ties in with Francis's data. He's going out and going, hey, this is a slum, non-slum area. All of a sudden, hey, there's training data set. That's what we got to work on. Here's our training data set to go after this. So we process all this to a 100-meter grid and resample it and go after it. And so one of the biggest things is, and if you've ever worked in this field, is getting training and validation data. We've struggled with this for years because what happens is everybody has a different definition of what a slum is. I don't even know what a slum is. All I know is whatever somebody tells me because it's really hard. And, me, Sarah was talking like she knows, and so what we've done is we put this in their hands. That's what kind of what Frances is doing is she's able to look at, okay, in our computer program, she can go on her mobile phone and go, you're wrong there, or you're right there. And so that's what's trying to help us out. And so what we do is we have binary training data sets from Idea Maps Community Survey, Slum Dweller International, Frontier Development Lab, wherever we can get data from it. And then what we've done is taken into this idea from the PAR data set that Francis is working on, is they're going in and saying like, hey, in some of these areas, this is a super deprived, this is medium deprived, this is not deprived. Well, how many points do you think Francis has? About 200. And so if you know anything about artificial intelligence and machine learning, what do you know? That's nothing. And so that's what our big problem is right now. So in this case, with the binary training labels, we have about 1,300 training sites. And so we have pretty good models to be able to do that. So this kind of gives you all the stuff we're trying to do. So I've talked about our data processing, pre-processing, and integration. We're trying to test a whole bunch of machine learning classifiers right now. And then on the binary training labels, because we have enough training data to do that. And then we do an F1 score, precision, and then also a visual inspection. This is something that you see with a lot of the slum models is like, hey, they'll look really good on the training and validation data set. And then you look at the whole city and you're like, oh, that's not very good. And so one of the first things we do is look at it, okay, what does it look like spatially? Then how well does it look like on the statistics? And you come up with this binary output. Well, in order for it to come up with a binary output, we also found out that a lot of these algorithms say like, okay, we have about 76% probability that it's this or that. Well, what we started to think about was, can we use that probability to then go after a degree of this variability? And that's kind of what we're testing here is, we get these things fit pretty well. And then we have this tiny little PAR data set. How well can we predict it with that probability? It says like, hey, we're really confident that this is a slum. We're less confident that it's a slum. And then how does that represent the different variability? This is what we're trying right now, having a high, low, or medium. And this is our results. So for random forest, we get pretty good accuracy. This is the binary training results. Precision about 0.91, 0.76 recall. So we're over predicting. F1 of 0.94, kappa 0.79. We can do pretty well for binary. And then this is what we do, our degree of informality. Look at this recall and F1 score. Ugh. And so what is our answer? We need more data. We don't know. And so what we're trying to do is figure out like, hey, because we have such a limited data set, like, can we start to think about what else we can do? And this is kind of where we're at right now. Is like, let's think about where else we can go. What are we able to do about it? And, what is our next steps from here? And if you have any ideas, let me know, because I'm open to them. But this is really, really hard to do when we're doing this. And this is what I'm talking about. So this is the entire study area for Nairobi. And then each one of these dots is one of their points. And what you look at is we just don't have enough information to make a really good model. And this is, I was talking to the number of people from the World Bank today and stuff like that. It's just the limited training and validation data to do any of these high-end decisions. It's really difficult to do. It's the dream as I look at it, and I got to think about, okay, what is a better way to go after it? Do I make fake data? Do I go after all these other methods that most machine learning people do? that's where we're at. It's very difficult to go after degree of deprivation. That's what I'll say right now. And so like the lead PI on our project has pushed me to it, and I just go, how can I do this? And so this is what I'm out here now, is trying to preach to people and try to figure out like, hey, what is a better way to do this? Because like there's actually not that many areas that are medium. It seems to be that, and it's really hard. And so training data are difficult to create. Okay, and what is the definition of a deprived area and the uncertainty with it? And Monica and I have talked about this with her Idea Atlas project. Yeah, isn't it Idea Atlas? And it's just like she's trying to do it for all these different cities, and she's like, yeah, it's so hard to pull in all these data sets, and everybody has a different decision. So what do? One of the big things is, look, we brought in all these geospatial data sets. A lot of them I don't think help. Um, and so that's kind of what I'm worried about, is like, how do we start cleaning up and parsing those things out? Because I think that's going to give us a lot of error with all these different things. And then, we got to test on our other cities where we might have better validation data and so forth. So this is kind of where it's at. And part of the whole Idea Maps network is, okay, the idea is you tell us from people on the ground, what do they want? What are they going after? We try to model it. And then we come back with our model results. Hey, this is what we're limited to. Now let's go back in this feedback loop. How do we start to improve it? Where do we go? What are we doing with it? And this is one piece of it. And so this is what I wanted to show today, is just like, hey, it's not always super easy. And how do we start to kind of go through this feedback loop again? And this is what we're doing next. And Sebastian and I are talking, we'll be meeting in May. Like, where do we go? Like, what inputs do we get rid of? Which ones do we try to improve and so forth? And start discussing this going forward. Okay. Any questions?
Yeah, that's good. If you could, if you could talk a little bit more about the challenge of the data noise, and like in particular, knowing the various things that are baked into, I think you said the 53 like global coverage data sets, and all of the like collinearity that like absolutely has to be in there. Where do we even start to dig out from under that mountain?
So one of the things we do is like, we've been trying to go after, one of the things we do is there's like a whole bunch of like machine learning methods of like, taking data sets out and pulling them out and putting back in and stuff like that. And so that's kind of, there's like grid CV and some other different approaches to go after that. And that's what we're trying to work on right now. The second thing is, what I've learned is if you eyeball it, like, and this is the whole thing. It's like, you just look at it and you go like, does that look right? It's amazing. Like, if you just spend some time like opening up something and overlaying it, okay, here's where we know we have really good training data. Does it even catch that? And that's kind of what the next step is. Like right now, we've just kind of thrown everything in because we've had a really big push, like here's the domains of deprivation, but like, and we have these theoretical models of what should be there. Are those actually true? And then are they the same in every city? And so this is a huge, huge question. And so this is kind of, like, yeah, you can look at there's definitely multicollinearity, do you run PCA and just kind of, but then you kind of lose the data set, and there's a whole bunch of drawbacks to that. And so these are all the things that we're thinking about, but yeah, I mean, that's what I'll be doing in this summer. Yeah.
This was really interesting. So I had two questions. One was, if you could explain a little more about what you really mean about like medium intensity, compared to like, or medium informality. Is that like lacking a certain subset of services or proportion of the population that lacks? Like, how would that be defined? And then secondly, how to maybe think about crowdsourcing, qualitative data and adding that in. So either doing like mobile-based, snowball-based samples of certain areas that you're targeting to get those data points. You can send out, there's these surveys via WhatsApp, I think you can send out and try to survey people and ask questions about what's your connectivity to formal water source or internet or air conditioning, these things that you might be wondering about. As well as, I think, just, yeah, creating a network of like the local communities to do qualitative surveys and incorporating that.
So there's two things there. What do we consider medium? Right now, it's when, there's two ways, is it, when people are making a decision, is it slum or not a slum? And when we have a lot of uncertainty in that, that's what we put into the medium category right now, where some people say it is and some people say it's not. And so that's kind of what we said, okay, this is medium because some people said it is and some people said it's not. That's what we're defining it right now. We don't have a formal definition because it's really hard. Because this is the whole thing, like if you can't even decide what's a slum and what's not, what's medium? And so that's kind of what our uncertainty is. The snowball approach and water points. And so one of the things, we're also working on a model of wash in some of these areas. And so, yeah, like there's people doing this. The problem with that type of data is that's not gonna be globally available. And so that wouldn't even be something that we could do in a model that we could do everywhere. And so this is the kind of the trade-off, like if you want to trade off between, a model that can be done everywhere versus one that's super specific, you got to make that decision. And so this is, for this work, we want to go after something that can be done everywhere, theoretically. And so like, yeah, that might improve our model, but like to what degree is that important for this type of work in terms of being able to do it? And you can make a one-off model and make it fit. Like I could probably spend a lot of time and make a one-off model and fit super, super well. But how replicable is that? These are the things I start thinking
Just sort of online,
about.
but maybe while I'm. I'll use the mic just so. One other, so we did some work with Lehman College and did some mechanical turking where we basically looked at, this Google Street View, and then, so that's a way to kind of like ramp up the number of data points using Street View and stuff. So have you been thinking about that?
We have, but like, I don't know if you caught it, like in the last thing, that whole thing with the online model validation, that is the point of it, is to generate these training data for it. And so we're trying to use that instead, so that way we have it all coming from one source. But yeah, I mean, there's only so many people and so much time. But yeah, I'd love to have Mechanical Turk.
Diane Wakanyo asks, I empathize with the challenge of defining deprivation. Part of the reason is that it's so relative and subjective. I'm wondering how the subjective / qualitative aspects of residents' views across the city have been captured.
And so how it's been captured is, so when they do the PAR data, they have people, they'll sign in and say, hey, are you a community member? Are you a researcher, or are you working for the city, and so forth. So we have information about that. And so that's kind of how the people who are validating these models, we have information about them. And then, like I said, when people are clicking on it and there's uncertainty and people say, yeah, it's a slum or not, it's not a slum, that's where we get that range in value. And so if everybody agrees it's a slum, then that's the high value. That kind of is where it's at. Anything else?
I mean, Idra Klein asks, with data privacy and protection, what protocols are in place to ensure such? I think we covered that a little bit in the morning, coarsening, resolution, things of that sort. But if there's anything more you wanted to say, and then I think I'll pass it back to Dana.
That's kind of why we've gone to the 100-meter grid cell, is because you can't really identify an individual. But we've had that discussion, should it be bigger? And this is where Dana is saying like, hey, if she goes for street blocks, that is a pro and con. And It's tough. I mean, I just don't have an answer because you need the high resolution data to train it. And, we don't really give that data out. And so there is protocols for that as well. So we're in between.